video, I'm going to solve 3 examples on limits. Before I go into that, I would like to emphasize that before you start solving a problem on limits, the first thing that you have to consider is direct substitution. What do I mean by direct substitution? So direct substitution, there is when you are evaluating a limit, there will always be that value which x approaches. Like in this example, the first example, you have the limit as x approaches -2. So before you start evaluating the function, the same limit, you have to do direct substitution. You substitute where there is x, that value which x is approaching. So let's start by evaluating the first example. So in this case, we'll start by direct substitution so that we check if the function is defined or undefined. So the first example, we're going to do the direct substitution, and when you're doing direct substitution, you don't have to show the limit as x approaches something, no. Just substitute like that. So you have -2, when you substitute -2 where there is x, you have 3 -2 plus 4 over -2 plus 5. So what is 3 multiplied by -2? That is -6 plus 4 over here you're going to have 3. -2 plus 5, that's 3. So -6 plus 2 plus 4, you get -2 over 3. So we can see that this function, just by direct substitution, the function is defined. Meaning what you've gotten, this is the limit for this function. Let's move to the next example. In this example, you have the limit as x approaches 0 of the root of x squared plus 100 minus 10 over x squared. So the first step, as usual, direct substitution. So in this example, when you get your x equal to 0, you substitute where there is x squared here, you're going to have the denominator as 0. Meaning this function will be indeterminate. In short, or in other words, it will be undefined. So in that case, you need to find a way to evaluate the function, meaning that means you manipulate the function before solving it. So how do you manipulate this type of a limit? So you check the function. You can see that in the function you have a radical, the root of something, meaning you have to think of rationalizing the function before you do direct substitution. So let's rationalize the function. So how do you rationalize these types of function? When rationalizing, we know that you have to multiply the numerator and the denominator with the conjugate of the numerator, because the numerator is the one having the square root there. So let's now move forward. You have the limit as x approaches 0 of root x squared plus 100 minus 10. So you're going to multiply this numerator by the conjugate of this same function. What I mean by the conjugate, you're going to multiply it with the same function, but you're going to change the sign which you have from negative to positive. So you have the root of x squared plus 100 plus 10 this time over x squared. Even the denominator, you multiply it with the same function, which is the root of x squared plus 100 plus 10, like that. So you can see that on the numerator there, you have difference of 2 squares. You have the same things multiplying, only signs are different. So you don't have to start multiplying each terms that you have. No, just multiply the corresponding terms. What I mean by corresponding terms is just multiply this term that you have with this term, this sign with this sign, and this number with that number, because this is a difference of 2 squares. So you are going to have your limit as x approaches 0 of when you multiply this and that, you're going to have x squared plus 100 minus negative and positive, you get a minus, 10 and 10 there, you get 100 over the numerator. Just write it the way it is. Don't do anything to it. You have x squared, the root of x squared plus 100 plus 10. So where we reached here, you can see that 100 and 100 can cancel because they are subtracting the same magnitude. Then you remain with the limit as x approaches 0 of x squared over x squared, the root of x squared plus 100 plus 10. Since what you have on the denominator, this x squared is multiplying this odd term, meaning you have this multiplying this odd term, and on the numerator you have the same thing, which is x squared. So here you just have to cancel. You cancel that x and that, meaning you remain with the limit as x approaches 0 of 1 over the root of x squared plus 100 plus 10. Now, where you reached here, you can't simplify any further, meaning just do direct substitution again. You see what you get. The function will be defined or the function will be undefined. So when you get your x equal to 0, you substitute where there is x, you are going to have 1 over, here you have a 0, meaning you are going to have the root of 100, which is 10, plus 10, which is 20. So this is 1 over 20, meaning this function has been defined. So what you get there, this is your limit. So we are going to evaluate our last example now, which we have. So this example is asking us to evaluate the limit as x approaches negative 2 of x plus 2 over x squared minus 6x minus 16. So as usual, direct substitution. So if you get your x equal to negative 2, you substitute where there is x here, you're going to get negative 2 squared, which is a 4, minus where there is x, 6 multiplied, negative 6 multiplied by negative 2, you get your 12, positive 12 minus 16. So what you have here is 16 minus 16, giving us a 0 there. So that means this function is undefined when you substitute your negative 2 there. So what do you do now? You manipulate the function now before direct substitution. So how do you go about manipulating these types of functions? So you observe the function before you do anything. So if you observe the numerator, there is nothing that you can do to the numerator to manipulate it further. But if you observe the denominator, you have a quadratic function as your denominator. So what do you do to a quadratic function? You factorize it. Using the you factorize it. So how do we factorize it? Can factorize it? Yeah. So you have this as your x squared minus 6x minus 16. How do we factorize this? You can use the concept of product, sum and factors to factorize this kind of a quadratic function. So what's our sum? We have our sum, which is negative 6. And what is our product? We multiply the coefficient of this variable, the first variable, by that, which will just give us negative 16, like that. So from there, you find the factors. What are your factors? Two numbers, when you multiply them, they'll give you negative 16. Again, those same two numbers, when you add them, they'll give you negative 6. So what are those two numbers? You have negative 8 and 2. So when you multiply negative 8 and 2, you get negative 16. When you add negative 8 plus 2, you get negative 6. So these are our factors. So let's now factorize what we have here. So factorizing what we have, you substitute your factors where there is sum. There, you factorize you substitute your factors. So you are going to have x squared plus 2x minus 8x minus 16. And then here you can factorize them by grouping them. You factorize this part, then you factorize that part. So here what is common is x. X is on both sides. So you have x there, and then with x plus, if you factor out x here, you have 2. Here, when you factor out negative 8, because negative 8 is common, you're going to have a negative 8. Here, you remain with x minus or x plus, because I factored out negative 8. So you have 2 here. So this is what you have. So these are the same, you just get 1. So you have x plus 2, x minus 8 as your factors of this function. So now, moving forward, meaning after factorizing, you substitute, because you know that this is the same as that. So we're going to have the limit as x approaches negative 2 of x plus 2 over what you have. Instead of writing this, you are going to write the factors of it. You are going to write the factors of this function. So x plus 2, x minus 8. From here, you can simplify further, but you know that on the numerator you have this, and then on the denominator you have this multiplying with that. So these two can cancel, and then you remain with the limit as x approaches negative 2 of 1 over x minus 8. And then where you reached, you can simplify this further. So you do your direct substitution. So where there is x, you substitute the value of x, which will give us 1 over negative 2 minus 8, giving us 1 over negative 10, which is just equal to negative 1 over 10. This is our limit. Thank you.